Hi friends, I am here to present the project 128 Tap FIR filter using hardware accelerator implementation. This is a software version. So basically I'll be opening my Quartus 2. I have used two more tools, that is QSys and Eclipse for Neos 2. So I'll be opening my project. Next I'll be selecting the folder which I have already created in that software. Then I'll be giving the project name as SFIR, as in software as FIR. Next I'll be selecting Cyclone 2 because I'm using a D1 board and it has Cyclone 2 processor on that with 484 pins. For simulation I'll be using model sim. Finish. I started a project. Now next step would be opening QSys, which is a system generating file. Here I'll use Neos 2. There are three basic versions of Neos 2. I'll be three versions of Neos 2. I'll be using the economic version, and next on chip for the memory I'll be changing it to 20480 bytes, and for communication I'll be taking the JTAG UART, and for checking my performance I'll be taking performance counter. And now I have dragged all the peripherals. Now I need to connect all the peripherals. So this is the clock connection which I have to give it to all my peripherals in my project. This is the reset and the data master. There is an instruction master which is used to fetch instructions to the on-chip memory. So just I'll be connecting that. There are interrupt which I have to connect. Now I'm left with few errors. This is because I haven't assigned my base address here. So I'll go to the system, assign base address. So my base addresses are assigned now here. Now I'll save the software. I'll save my system as an SFIR. Save. Next I'll generate. Before generation I have to go to Neos 2 and and give the connections to the reset vector and exception vector. So now I am left out with 0 errors and 0 warnings. Now I am free to go to the generation thing and generate my verilog files. Now this here, when I click generate, it generates all the verilog files which are related to the design or the system which I have generated in the QSys, and I'll be dragging these verilog files into my Quartus to compile it. So I'll drag the verilog files. So here are few verilog files. Here are all the verilog files, and there is a QIP file which is kind of an image for all the verilog files. So when I select just one QIP file, I can call all the verilog files. Add, apply, okay. So here is the QIP file. I have dragged the QIP file, right? So I have to assign pins. Basically all the pins are in the FPGA. I need to only supply the clock for the pins. So I'll be taking the clock and here is for input. I have given the pin assignments. Now I'll save my project and compile it. Meanwhile, in the compilation time, I'll be going to the Neos 2 software building where I can write my C code and run the project and see the output. And this is the Neos 2 where I'll write my C code and check the output, and also I'll open my process programmer thing. As soon as the compilation is done, I'll put my project onto my board, DE1 board. So once the compilation is done, I'll add the file, output file, SOP. Okay, select this, I'll start. So it's 100% successful. I'll save this, save, close it. Now I'll go to the NEOS 2. Here I'll be calling SOPC info file, which has all the information about my project, and I'll give a name for that. So I'll uncheck this. I'll be using a smaller template of a C file. Now this is importing all this workspace where I can write down my C code and check it. Right click on this. First I'll build the project. This is the building the project is kind of making a communication between the board and the software. Once build project is done, I'll be running my hello world default code, which is generated by the software itself. And then once it is done, so building is done, that means the communication is formed, and now I'll run the default C code which is already there, run as NEOS to hardware. So here my board has responded to my C code, that is by saying hello from NEOS 2. Now I'll open the C code. I'll select, I have written a C code for this, so Control C, I'll paste it here, and I'll check whether my performance address is same, my performance counter addresses are same or not. Here my performance address is okay. Now I'll save my C code, save it, then again run it. So once it has started running, and here are number of cycles from which are consumed by my FIR for my FIR calculation, and here is my FIR calculation. My FIR output is -34, and the number of cycles it took is 173760. Basically I have taken the first case, so the output for the first case is -34. This is in the software version. So I'll exit the Eclipse, and I'll show I'll compare the software thing with